All right, so continue. Okay, so we're going to do a fraction equals a fraction. But we'll make sure the example is a good one. All right, here we go. Okay, so in order to get rid of the fractions before you start, you cross multiply. That is, multiply across, and that only happens when there's an equal sign. So this would be 3 onto 3x minus 5 is equal to x times 2. And then multiply that through. So 3 times 3x, 9x. 3 times 5, 15, and that's a minus. X is to one side, numbers to the other. So the 9x is already on this side. Bring the 2 over, becomes a negative. That's a negative 15 on the left, so on the right will be a positive 15. over 7. Okay, so if we have a fraction equals a fraction, the method is the same, and in fact what you do when you're solving for x, when it's just linear, is you get a linear expression with no fractions to start, and then you go through and solve that. Okay, so that's the idea. Now it could have, this is called a rational function because there's x's in it instead of a fraction, and that side's a fraction. Okay, I just said fraction equals fraction. We could have examples like with x's on both sides. And we do the same method, so we multiply the 2 across and the 3. So we'll have 3 onto 2x minus 4 is equal to, that's the equal sign, 2 onto x minus 1. Expand both of these, so 6x minus 12, and then 2x minus 2. Bring the 2 over and the 12 that way. So the 6 is staying, minus 2x, the minus 2 is staying, and move the minus 12 becomes a plus 12. Now, usually I'll put simplify your answers. So that one does simplify, this one didn't, but this does. What would it be equal to? 5 over 2. Okay, so that's fraction equals a fraction. Now we get into common denominators first. So that would be when, so these examples here have two terms. They have one term on each side of the equal sign. A term is something, this divided keeps that all together as one expression. Whereas, say that 2 wasn't there. Okay, so say we just had like 2x minus 4. This has two terms. But as soon as you divide it or multiply it by something, it's now held together as sort of one term. So the next few examples actually start with 3 terms. Then we need to get them to 2 terms so that we can cross multiply, so that we have an expression that has no fractions in it, and then we solve it. So it's sort of like one step before this. Okay? So when you do a common denominator, like your whole idea when you're looking at these is actually just to have one term or one fraction or one number on each side of the equal sign. So you do not need to put this 2 over the common denominator 4, for example. This is just one term on this side of the equal sign. We need one term on the other side of the equal sign. So we need to put, there's 3 terms right now, 2 of them need to go together, so we have 1 and 1. So here, we're going to find the common denominator, which is what? Is 12, right? So we'll multiply the first one by 4. And the second one by 3. And like I said, that's just equal to 2. You don't need to put that over 12 as well. So we've got 8 onto x minus 1, minus 3 onto 3x plus 1, all over 12. We can work out the numerator, so this will be 8x minus 8, minus 9x minus 3. What can we do with that 12? That would be the cross multiply bit, yeah. So I'm just going to finish the top first. We have 8x minus 9x, negative x, and minus 8 minus 3, minus 11. Okay, so what we've done, we found a common denominator, put it together, simplified it. That's what we did in the last chapter, or the last section. And then now we've got the fraction equals a number, and we can cross multiply. So the 12, so minus x minus 11 equals 2 times 12. And what I normally do if I've got a minus x, normally I would just move the x to the other side so that it's positive, but you can not do that and divide both sides by negative after. But I did say earlier, in our inequality section, moving the x to be positive is always a better idea, so I just sort of do it all the time. I'm going to move the 24 to that side. So x, and that's a positive 24, so it will be a negative 24 on this side. Negative 35. And I just flipped it around. So that was a negative 11, stayed on this side, and the 24 was positive, so when it comes over it becomes negative. The x was negative, when it comes over it becomes positive. Questions? We're okay? Number 2. Common denominator? 15. So I'll multiply the first one by 3, and the second one by 5. And you don't need to worry about the 1. So 3x over 15 minus 5 times 2 is 10x over 15. So 3x minus 10x altogether over 15. There. We have a fraction equals a number, so we can cross multiply. Minus 7x equals 1 times 15. this is fine. You wouldn't get marked wrong, but normally we see the equal sign on top or in front, not on the bottom, but it's not wrong to be on the bottom. Oops, 3. Okay, so this example does have 3 terms when we start. We've got a fraction on one side and then a linear expression on the other side. So it does have 3 when we start, but do we need a common denominator? No. Can we go right to cross multiplying? Yeah, so it's okay to have 3 terms as long as you can sort of treat one term, or 2 terms as one thing. So if you think of that as 4x plus 1, when we cross multiply, that 3 has to be multiplied by both of those terms. So we would have 2x minus 5 is equal to 3 onto 4x plus 1. Make sense? So that's okay. So we'll just finish this question. 3 times 4 is 12, plus 3. So 2x stays, move the 12 over, it becomes a minus. The 3 stays, move the 5 over, it becomes a plus. I move the minus up to the top here, which doesn't matter. It's not that the 10 is negative, it's that the fraction is negative, so that negative sign can go anywhere. It's like a minus 1 times the fraction. So I just moved it up to the top to be more standard and reduced it. Okay, so this one's okay, right? Well, I could have put this in the last part where I said a fraction equals a number and done it that way. But sometimes it looks a little different, like number 4. So what if it looks like this?
You put the 6x on the other side of the equal?
Yeah, and you may not have thought of that before if I didn't do that other example first. But this has 3 terms. You don't need to do a common denominator. You don't need to combine these 2 together. You could just move the 6 over so that you can avoid the common denominator part. Doing the common denominator here, putting a 1, multiplying it by 3, that works, but it's longer. So if you notice that you can rearrange something before you start, 4 plus 6x, so moving that minus 6x over to the other side, then we've got a term that we can cross multiply the 3 with. So 2x minus 3 is equal to 3 onto 4 plus 6x, or 6x plus 4, it doesn't matter. Multiply that out, or expand it. So 3 times 4 is 12, 3 times 6 is 18. 2x minus 18x, and 12 plus 3. And numbers that are only 1 apart never reduce. So 15 and 16, you don't really even need to think about it. And I say that for these, although you would know that they don't have a common factor, but if you had 144 and 145, they're 1 apart, they won't reduce. Okay, so just that applies to every 2 numbers that are 1 apart. Okay, questions? So you can sometimes avoid doing a common denominator when there's 3 terms. Okay, so look at what you have first before you jump right to a common denominator. So, exact same thing. Right, we do have only one fraction. Usually you want to do the common denominator when there's two fractions. So we can move that 1 over. 2x plus 1, cross multiply. So 2 times 2 is 4, 2 times 1 is 2. Do you see what's going to happen? We did that last class. What does that mean when that happens? When all the x's disappear, but there's still a number? If it's not 0, it is no solution. Cross multiply. Move the x and the 4, so x minus 4x equals, there's already a minus 4 on this side, and be careful when the numbers are the same. If this is a negative on this side, move it over and becomes a positive. So what does this mean? Zero over a number is okay. It's a number. It's an answer just like 5. Right? It's on the number line between -1 and 1. It's a number. So be careful that you don't say no solution when the answer is actually 0. So 0 is the solution, x equals 0. If I were to check that in the original, so our original left-hand side, if we put x as 0 in, we get 0 minus 4 over 2, which is minus 4 over 2, or -2. And the right-hand side was 2x minus 2. If we put 0 in, 0 minus 2, which is minus 2. They're equal, so it checks, right? So 0 is a number that you can plug in and get an answer. 0 is okay. A number, 0 divided by a number is okay. What's not okay? Number divided by 0, not okay. Which is undefined is the right word for it. Okay? This is undefined. That is the right math word for when something doesn't work. Okay, so let's see. What about this one? What would you do? How many terms are here, first of all? 4. Do you see the 4? So the x minus 1, I could make it look like one term by putting a bracket, but it actually still wouldn't be unless I multiply it or divide it by something. So x is a term and minus 1 is a term. Now, we do have two fractions with different denominators, so at some point we do need to find a common denominator. Your rule for any question that involves fractions is to figure out a way to get one fraction on each side. Okay, or a single number on one side and a fraction. So it can be a fraction equals a number or expression, or a fraction equals a fraction. So should we rearrange this to make it easier for us, or we could proceed from here? What do you think? There's different ways to do it. I might rearrange it, put the two fractions on one side, everything else on the other side. I might do that, bring this over, and then find a common denominator. You could do that. That would be one option. The other option is to make this into a fraction by dividing the whole thing by 1. Divide that by 1. What's that?
You can multiply the second term by 2 over 2, and you combine the fraction.
Yeah, that's what I'm saying. If you made this into a fraction over 1, you can multiply and make it a common denominator here. So that would be an option as well. So you could leave it how it is, make that into a fraction, and then multiply this by 2 over 2 to make a common denominator. Add those two together, then you have a fraction equals a fraction. Is one way better than the other? No, because you cross-multiply after that and there won't be any fractions. So it doesn't matter if there's one on each side or one and a single number. It really doesn't matter. We'll maybe just leave it like this and do what you say, which is multiply this by 2 over 2. So this would be x minus 4 over 2, and this will be 2 onto x minus 1 over 2. Okay. So we still have 3 fractions. These two have the same denominator, so it can be written as 1. Each line has to be equal, so make sure you just keep rewriting that. Here we have x minus 4 plus 2x minus 2. X plus 2x, 3x, minus 4 minus 2, minus 6. And then we can cross multiply. And now our fractions are gone, we can go ahead and solve it. So 3 times 3 is 9, 3 times 6, 2 times 2, and 2 times 3. Move the 4 over, and the 18. 9 minus 4, and 6 plus 18. Can that reduce? No, and we don't write mixed numbers, so you would just leave your answer that way.